Hey everyone, welcome back to Weld.com. So the other day we had one of our viewers submit a question through our new website, Weld.com. Fancy name, right? Just makes sense. And he wanted to know, he's building a welding cart and wants to know if he can use flux core versus solid wire MIG to finish out his welding cart. And there seems to be a lot of myths around flux core. I went ahead and answered his question, but I wanted to go ahead and bring the topic up to everybody. There's a lot of myths regarding flux core and that it's an inferior process, when actually it's not. Especially for you home hobbyists. You know, if you don't have the ability to run anything other than flux core on your machine, or you don't have access to a gas bottle, there's just a lot of stuff that flux core has benefits over versus solid wire MIG, or even stick for that matter. I mean, I've ran miles of this stuff when I did structural steel. It's a lot faster, you get better deposition rates compared to a regular stick weld. But it seems like a lot of people have a hard time running it. So today we're going to go through a couple of the common problems that you would run into with flux core. Hopefully that gets you a bit more accustomed to using flux core and using that over another process, especially if that's all you have at your shop. So let's go ahead and get into it. All right, today we're on the ESAB Rebel 235. I'm going to run about 180 inches a minute on the wire feed speed, 17 volts. I have some 035 Select Arc 701. It's a E71 T11. This is something you can't pick up this exact spool, but you can get some T11 at your local big box store. They sell them 1 pound spools, and then you get like 12 pound spools. We're going to go ahead and run 035 because that's pretty much what's common, what you can pick up at those stores. Like I said, it's a bigger spool. It's a 25 pound spool, but you can get them in about 12 and a half pound spools. All right, so the first misconception is you're going to get a lot of weld spatter and a high ropey bead profile. Now you can see, you know, as I'm welding here, I'm getting a crap ton of spatter, right? It's all over the place. And I have a very small puddle. It's a very narrow bead profile. If you're running into this problem, you shouldn't be. It's most likely your polarity. So right now I'm running on DC positive. I'm running the same settings, but I'm on DC positive, whereas I should be on DC negative. This is very common, especially if you're new to welding, you're just getting into it, you know, for you to set your machine up just as you would for most stick processes and all of solid wire MIG processes. So running on DC positive, that's exactly what we got here. You can tell we got a bunch of spatter on here. I mean, it's like horse crap in Amish town. It's everywhere. We got the high ropey bead profile, didn't tie into the sides, so that's another misconception, is you don't get enough penetration. We're going to discuss that a little bit more in depth later. And for those of you that think that that's just sprinkled on there, we went ahead and hit it with a wire wheel. On the back side, we did another weld, cleaned it up with a wire wheel. All this stuff is really caked on pretty strong. The problem is with DC positive, I have about 70% of my heat on my wire, 30% of the heat on the base metal. That's a lot of current to be running through that small wire, because remember, it's hollow and it's packed with flux, right? There's granulated flux inside that wire, right? So I'm putting about 70% of my amperage on the wire, whereas I should have it on my base metal. All right, so with this, we can alleviate all that trash just by switching our polarity. You'll notice that when I was running the previous pass on DC positive, I'm only averaging about 105 amps. We're gonna go ahead and switch the polarity. We'll get an arc shot of the amps as well as the weld and the final product, and we'll show you exactly what we're talking about. So now I'm just gonna switch. This is the power to my gun or my electrode, and this is to my workpiece clamp or grounding clamp. I'm gonna go ahead and switch this to the positive, and this electrode, the electrode I'm gonna put into the negative. So now I'm on DC negative or straight polarity, okay? We'll go back, run another test weld. We'll get some information off of here. I'm not going to change any of the settings. I ran 180 inches a minute and 17 volts when I was on DC positive. I'm going to do the same thing now that we're on DC negative. All right, so as you can see, just by switching out my polarity to DC negative, I'm getting a much smoother bead appearance. So that spatter is virtually gone. The weld is spreading out much wider. I'm getting better penetration in here. I've got better wetting into the toes. And as you'll be able to see on the flash screen there, I went from 105 amps, now I'm running at about 146. And that's roughly, you know, that's just by switching my polarity, okay? That's actual 71% difference between the two. So now I have 70% of my heat in the base metal, 30% on the electrode, just by switching the polarity. All right, let's go ahead and clean this up, and we'll take a look at the final weld. All right, so there's no spatter left on here. I hit it with a wire wheel. I didn't have to do any additional grinding or anything like that to get rid of the spatter. and I have overall smooth, clean, uniform bead appearance, right? Good wetting into the toes. There's the high ropey bead profile is pretty much gone, or it's completely gone. And it's a much smoother weld. We're gonna go ahead, we'll cut one of these apart and we'll show you the actual depth of penetration too, because that's another common misconception is you don't get the same penetration with flux core as you do with the other processes, when in fact, we're probably gonna get more, if not the same. All right, so that brings us to the misconception number 2, which is lack of penetration, or short circuit MIG would penetrate better than flux core. So down here I've got the flux core piece that we did. We also ran a solid wire MIG. Both of them are right around 140 amps. We're gonna go ahead, cut, polish, and etch these, and check out the penetration profile. All right, so we've shown this in a previous video, but we're gonna go ahead, we're just gonna go up in different grits on these pieces until we get like a relatively decent polish. Doesn't have to be mirrored polish. The closer you can get it to a shiny mirror, the better off you're gonna be. But we're just gonna polish them up, and then we're gonna use some 10% ferric chloride on there and kind of expose the little weld nugget we got going on. All right, so as you can see on your left, we have the short circuit MIG sample, and then on the right, the flux core sample. So with the short circuit MIG, you know, it's prone to lack of fusion. It's still good for 1/4 inch plate, which is what we have here. You can tell on the vertical leg over here on the short circuit side that you have a little bit less penetration than you do with the flux core. Also, you know, you can see that you got a little bit more punch with that flux core. So if you're using flux core at the house, you shouldn't have any hesitation about using that, you know, on thicker materials. Whereas like with short circuit MIG, you know, 5/16 is going to be your capacity on that. With flux core though, I mean, you can go much thicker material and still not have any worries about getting good penetration in there. All right, so the next misconception that's often associated with flux core, especially self-shielded flux core, is porosity. So the biggest thing that can contribute to your porosity is, number one, obviously improperly stored electrodes. We did a video on that a while ago. You can check that one out. But the next main culprit of that is your contact tip to work distance. So the wire we're using today, this 71T-11 in the 035 diameter, it's recommended for 3/8 to a 1/2 inch stick out. Now I'm going to show you if you get too close what's actually going to happen. So by too close, I mean anything less than 3/8, if I get that, you know, start burying that contact tip in there, I'm most likely going to get porosity. We're going to go ahead and run through. I'll put a weld on the back side of this and show you exactly you should get porosity. All right, so as you can see, we had that contact tip right up there, right next to the puddle. Left that contact tip to work distance really short. Didn't even have a nozzle on there. With self-shielded, you don't really need a nozzle. But with this, I wanted to try to get as close as possible to replicate some of the stuff that I've seen in the past. I've seen students do. This could be something you're running into at the house because you know, you're not familiar with the process. So hopefully we're going to go ahead and take the, all this slag off the wire wheel, and we should expose some porosity under there. Okay, so I got a couple good ones in here. There's some speckled right up in here. Got a good piece right here. Cluster porosity here. There's about 3 or 4 of them just in that one little pocket. Little here, and then definitely one right here. And then one on the end where we terminated. So what's going to help you prevent that is maintaining that proper contact tip to work distance. The problem is the flux on the inside of that tube, it has to preheat before it interacts with the weld pool in order for it to do its job. So think about firing up your oven, right? You can't just fire the oven up, throw a pizza in there, and come back 30 minutes later. It's not going to work. You want to preheat the oven to the proper temperature in order for it to cook efficiently. Same thing with the flux. You want to heat that flux up by maintaining that contact tip to work distance so it's preheated before it joins that molten metal pool. Not really a misconception, but what I've seen a lot of people face or have issues with when dealing with flux core is wire feeding issues. And a lot of that comes back to the drive rolls. So usually when I open the machine up, they have the improper drive rolls selected for what they're doing. So these right here on your left-hand side are V-grooves. Okay, these are great for solid wire applications. However, when we get into a flux core or metal core, where you just have an exterior sheathing of metal and the interior is filled with either granulated flux or crushed iron powder, you want to have some sort of grip on there to be able to grip that wire. Now, if you use the V-groove, what you're going to end up doing is crushing that wire, and you're going to get feeding issues throughout the liner. The knurled rolls here on your right-hand side, These are adequate for your flux core applications because they have a little bit of grip, so they'll be able to grab the wire and pull it through. Another thing you want to make sure is your wire tension isn't too tight. If it's too tight, you're going to crush the line in there, or you're going to crush the wire in there regardless. So make sure you have the appropriate diameter. So if we're using 035 or 045 wire, make sure you have the appropriate drive roll selected for that, as well as the type of drive roll, be it knurled or a V-groove. One other thing, if you are getting a lot of spatter and you know you have your settings dialed in correct, you know you're using the right polarity, all that good stuff, but you're still getting a lot of spatter, one thing you can do to kind of protect your table, I know that with hard facing, if you ever have to do hard facing, so not just the table but the material you're working on, if you take some anti-spatter and spray that on the surface, once you get done welding, you can take a lot of those BBs and just wipe them right off the table. It's going to provide a nice protective finish on there. You'll be able to wipe the table back off. Similarly, the material that you're working on, if you're developing a lot of spatter on that, you spray this in the welding area, you'll be able to wipe the BBs right off when you're done. It's going to save you a lot of time and prevent you having to do any additional grinding on there. All right, so you can see in this area where we did all our weld demos, we should have a bunch of spatter on here, but because we use the anti-spatter, we're just able to wipe all that stuff off, so we don't have to go back through and grind anything down on the table. All right, hopefully we're able to debunk some of the myths surrounded by flux core self-shielded. Kevin, I hope that answers your question, probably a little bit more thoroughly than you were looking for, but hopefully you were able to get something out of it. If you guys have questions, comments, concerns, you need help with a weld, you want to post pictures, get some feedback, go ahead and post it up on Weld.com. There's going to be a link in the description down below, and we'll help you out to the best of our ability. Hope you guys enjoyed the show. Until next time, make every weld better than your last.